All right, everyone, here, let's review something called literal equations. Literal equations. So what are literal equations? Well, these are just equations with more than one variable. All right, what makes that special? Well, let's take a look at something like, I don't know, x plus y equals 5, all right? And let's say we wanted to solve for x, okay? Well, normally when we solve an equation for a variable up to now, we were able to say that variable equals some number, right? Like just a real quick example, like x plus 3 equals 10, right? We were able to subtract 3 on both sides and just say outright x equals 7, right? These are the kinds of equations we've looked at so far. But right now we're looking at an equation with two variables. So what can we do with that? Well, we can, treat y as if it were a number. In fact, it is a number. It's just an unknown number. So we still want to get x by itself on the left-hand side. How can we get x by itself on the left-hand side? Well, just like in this equation here, we subtracted 3 to get rid of the term plus 3. We can just subtract y to get rid of the term plus y. No matter what number y is, plus y minus y, or positive y minus y, still equals 0. So that still cancels out, right? So x is still by itself on the left-hand side, and it equals what? What is 5 minus y? Well, let's look at our so-called normal equation. When we computed 10 minus 3, we were actually able to say 10 minus 3 equals 7, a definite number, right? Well, we don't know what y is. We know it's a number, but it's an unknown number as of now. So we can't simplify 5 minus y into a definite number, but we can write 5 minus y, and x does indeed equal 5 minus y. So a solution like this is completely valid, and that is how you solve a literal equation. Let's take a look at a couple more examples. Let me make some room for us here. Get some room here, get my color back in my brush. Okay, let's say we had something like W times 5 equals Z. Okay, W times 5 equals Z, and we wanted to solve for W. Well, let's take a look at what a sort of, normal equation would look like. What if we had something like x times 5 equals 10, right? Here's a normal equation, which has just one variable. And if we wanted to solve for x, we would divide by 5 on both sides, right? X would be by itself, and we'd have x equals 10 divided by 5 is 2, right? That's how we would solve this. Well, if we look up at our literal equation, it's very similar. W times 5 is on the left-hand side, but an unknown variable z is on the right-hand side. Well, if we want to solve for w, we can still divide by 5 on both sides to get the w by itself. That factor of 5 vanishes as it's divided by itself. W equals, what is z minus 5? Well, unlike this equation here, we can't actually calculate z divided by 5 because we don't know what z is yet. It's an unknown variable, but we can certainly just write z divided by 5. And again, that's a perfectly valid solution. We just want to isolate the variable which we are solving for on one side and have an expression involving all the other variables on the other side. Let's do one more example, all right? Let's do one more example, or two, maybe two. All right, let's say we had something like, let's say x plus, let's do this. Let's say x plus 2y, about this, let's say 10x plus 2y equals 30. That's better. 10x plus 2y equals 30. And what do we want to do? Let's say we want to solve for y. What does that mean? That means we want to get y by itself on that left-hand side. Okay, what do we have to get rid of? First, we have to get rid of every term which does not have the variable y in it. Which term does not have the variable y in it? The term 10x. So we need to get rid of the term 10x. We'll do that by subtracting 10x. And since we did it on one side, we have to do the same thing on the other side. All right, that term 10x is gone. On the left-hand side, 2y is by itself, and that equals 30 minus 10x. 30 and negative 10x are not like terms, so we can't simplify that, but we can perfectly reasonably write 30 minus 10x. That's fine, you can do that. Okay, and what should we do to finally get y by itself? Well, we need to cancel out that factor of 2 on the left-hand side, so we divide by 2 on both sides. And that factor cancels out. What does y equal? Y equals 30 minus 10x over 2. That's a valid solution. That is what y equals. We don't know what the value of x is, so we can't simplify that into a definite number. But every step we did was algebraically valid, so this is a perfectly good answer. Y equals 30 minus 10x divided by 2. All right, let's do one more. Let's do one more. Create some space for us here. All right, get my writing back. And let's say we had something like, say, x times y times r equals z. Something like this, okay. And what if we wanted to solve for r? Solve for r. All right, that means we want to get r by itself on the left-hand side. What's keeping r from being by itself? Well, it's being multiplied by x, and it's being multiplied by y. So we want to undo the multiplication by both x and y. So let's just divide by x times y. We can certainly divide by x times y. That's going to cancel out both the factors x and y at once. We have to do the exact same thing on the right-hand side. So finally, we do have r by itself, and what does it equal? It equals z divided by x times y. That's a perfectly valid solution to a literal equation.